For lesson 5, we're going to look at exponents. In the opening exercises, we're repeat adding. And so if we add 4 10 times, we'll end up with 40. And if we add 9 5 times, we'll end up with 45. And if we add 10 5 times, we'll end up with 50. Now, examples 1 through 5 look very similar to our opening exercise, except for one really important difference. And that is that in examples 1 through 5, we are talking about repeat multiplication, not repeat addition. So if I multiply 5 times itself 5 times, I'm going to get 3,125, which is very different from 25 that we would get if we repeat added our 5. It's also really important to notice that we could write 5 times itself 5 times as an exponent, and it would be 5 to the 5th power. The 5 represents the number that we're multiplying, and the small 5 as the exponent represents the number of times that we are multiplying it times itself. So looking at 2 times 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. So the value, if we evaluate it, evaluate means to find the value of that expression is 16. When we write it as an exponent, the 2 becomes our base, and our exponent is the number of times we're multiplying to, which is 4. So this is 2 to the 4th power. In number 3, they've given us the exponential form. So we're going to write it out as a multiplication problem first, and that will be 8 times 8 times 8. 8 being multiplied times itself 3 times. And the value of that, 8 times 8 is 64, and 64 times 8 is 512. 10 to the 6th power. Let's write it as a multiplication statement first. That is 10 times 10 times 10 times 10 times 10 times 10. 6 tens. And when we multiply them together, we're going to get 1 million. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. 10,000 times 10 is 100,000. And 100,000 times 10 is 1 million. Finally, we have g to the 3rd power. Now, g to the 3rd power written as a multiplication statement, g times g times g, 3 g's. But we don't know what the value of that number is because we don't know what g is. So we cannot get or evaluate it in terms of a single number answer. The difference between 3g and g to the 3rd power is a very important concept. 3g is g plus g plus g. However, g to the 3rd power is g times g times g. Which is very different. As you can see, adding g 3 times would be a relatively small number. Multiplying g 3 times could be a very large number, depending on what the value of g is. So in our examples 6 through 8, we want to first of all represent what is really going on, either as an exponent or writing the exponent as a multiplication problem. So in our first one, we're multiplying 3.8 times itself 4 times. And then we'll use a calculator to evaluate it. And so, using a calculator, we found that 3.8 to the 4th power is 208 and 5,136 10,000ths. In number 7, 2.1 times itself twice would be 2.1 to the 2nd power, which can also be read as 2.1 squared. Then, using a calculator, 2.1 squared is 4.41, or 4 and 41/100ths. Be careful when you are doing these, because there are some very common mistakes that we make sometimes, thinking that we know the answer without doing the work. In number 8, we have 0 and 75/100ths times itself 3 times. So written in exponential form, we would have 0 and 75/100ths to the 3rd power. And then using a calculator, we find that the value of that number is 0.421875. And just so we're clear on what the value is, let me say that we have 0 and 421,875 millionths. The base number in an exponent can also be a fraction. So they're asking us in exercises, in examples 7 and to convert the decimals to fractions in examples 7 and 8 and evaluate and leave our answer as a fraction. So let's go back. This is 2 1/10, or 21/10, and let's leave it as 21/10. Much easier to work with improper fractions than mixed numbers in this case. So in looking back at number 7, when we write 2 1/10 as an improper fraction, it's 21/10. And then raising it to the 2nd power, I put this in parentheses just mainly because I had some difficulty trying to represent an exponent in Word. When we raise it to the 2nd power, we are raising both the numerator and the denominator to the 2nd power. So it will be 21 times itself, which is 441, and 10 times itself, which is 100. And you can see that 441/100ths is the same as the decimal version. And then in the same way, 75/100ths to the 3rd power is 75/100ths, and I simplified it to 3/4. 3/4 to the 3rd power is actually, let's see if we can get there, 3 to the 3rd power, which is 3 times 3 times 3, which is 27. Over 4 to the 3rd power, which is actually 64. 4 times 4 is 16, and 16 times 4 is 64. So then in examples 9 and 10, we would follow the same pattern. 1/2 times itself 3 times is actually 1/2 to the third power. And what we find really interesting about this is that if you raise 1/2 to the third power, 1 to the third power, 1 times 1 times 1 is 1. 2 to the third power, 2 times 2 times 2 is actually 8. And so the value of the exponent actually decreases the value of the base number when you have a traditional fraction. So if we look at 2/3 to the second power, that would be 2/3 times 2/3, and we end up with 4/9. So then we'll practice in the exercises. We'll start with the exponential form. We'll write the repeated multiplication, and then the standard form, which is the actual number. So our first example was done for us. Second example has the repeated multiplication, and 2 is being multiplied times itself 6 times. So in exponential form, we would write 2 to the 6th power. In standard form, 2 to the 6th power is 64. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. In the third row, we have 4 to the 5th power. So we'll multiply 4 times itself 5 times. And 4 times itself 5 times is 1024. Then we have 3/4 times itself twice. So this will be 3/4 to the second power. And its value, 3 times 3 is 9, and 4 times 4 is 16, is 9/16, which again, you should notice is smaller. It has a lesser value than 3/4 individually. But when we multiply a fraction times something, we actually end up with something smaller than that. So if we multiply a fraction times a fraction, we will end up with a value that is smaller than our original fraction. And then finally, we have 1 and 5/10 being multiplied times itself twice. So that is 1 and 5/10 to the second power. And the value of that number is 2 and 25/100. Knowing that we have a fractional part might make you wonder why this is larger, but it's larger because the value of our original number is more than 1. It's 1 and 5/10, so it is bigger than 1, and so our final answer will be larger than the original number. They ask us then to write 5 cubed in all three forms. 5 cubed is 5 to the third power. And then that is 5 times 5 times 5. And then it's standard form. 5 times 5 is 25, times 5 is 125. Next we have 14 and 7/10 squared. So 14 and 7/10 as a decimal. Squared means to the second power. And that is 14 and 7/10 times itself twice. And the value of that number is 216 and 9/100. In question 4, one student thought 2 to the third power was equal to 6. What mistake do you think they made, and how would you help them fix their mistake? Well, first of all, 2 to the third power looks like this in exponential form, and that is equal to 2 times 2 times 2. You might already realize that what they did was to add 2 to itself 3 times rather than multiply. So in order to help them fix the mistake, we would want to write out, or help them write out, 2 times 2 times 2, and then multiply 2 times 2, which is 4, and 4 times 2, which is equal to 8. Remember, exponential notation for whole number exponents, just meaning that the exponent, the small number, is going to be a whole number, is written as the base times itself, the exponent number of times. Okay, this is all, it loves to be kind of confusing to write in a mathematical rule. But we are taking the base, the large number, and multiplying it times itself as many times as the exponent or the small number tells you.